Hello, my name is Lauren Nguyen, and my Teach 1 will discuss the evaluation of SQL predictions for the HAP 671 course. This presentation will cover likelihood ratios, contingency tables, sensitivity and specificity, and receiver operating curves. So what are likelihood ratios? Likelihood ratios are used to assess the strength of evidence provided by data in favor of one hypothesis over another, and are often used in a diagnostic testing to evaluate how much more likely a positive or negative test result are in individuals with certain conditions compared to others. Contingency tables in the context of likelihood ratios are used to organize data in a way that facilitates the calculation of the ratios. So looking at this table, the rows represent the presence or absence of a disease, and the columns represent positive or negative test results. The box marked A is considered a true positive, where the test is positive and the condition is present. The box marked B is a false negative, where the test is negative, but the condition is present. Box C is the number of false positives with a positive test result but absent condition. And box D is the number of true negatives, where the test is negative and the condition is absent. Using this table, likelihood ratios can be calculated. So the left equation tells us how much more likely a positive test result is if the condition is present versus if it's absent. The right equation does the opposite and tells us how much more likely a negative test result is if the condition is present versus absent. Likelihood ratios use sensitivity and specificity to assess the performance of a diagnostic test. Sensitivity, or the true positive rate, measures how well the test identifies individuals with the condition. Specificity, or the true negative rate, measures how well the test identifies individuals without the condition. As you can see here, the likelihood ratio of a positive test is sensitivity divided by 1 minus specificity. And the likelihood ratio of a negative test is 1 minus specificity divided by, is 1 minus sensitivity divided by specificity. Receiver operating curves shows the performance of a diagnostic test across different thresholds by plotting sensitivity on the y-axis and 1 minus specificity on the x-axis. The point closest to the top right corner is considered optimal because it represents the highest sensitivity and specificity. So this is an example of sample code. The code begins by creating a temporary table from the ROC data table and ordering it by the predicted probability and assigning row numbers. A temporary cutoff table is created which calculates cutoff points between each pair of adjacent probabilities. The temp1 table is created by applying these cutoffs to the ordered data, creating binary predictions based on whether the probability exceeds the cutoff. The senspec table is then created, which calculates sensitivity and specificity for each point. The code ends with the selection of cutoff, 1 minus specificity or false positive rate, and sensitivity, which allows us to plot the ROC. This slide shows the result from the query above, and the plotted ROC ends up looking like this. Thank you for listening to my presentation.